Good afternoon, good morning still, everyone. We are you forecasting food. My name is Raquel, along with Joel, Andrew, and Matthew. So our project tackles the issue of food waste worldwide. Wasted food accounts for 28% of agricultural land waste, 45 trillion gallons of water, and 8% of greenhouse gas emission. Our focus is on food waste at a university level. As you all may know, food planning at a university level is difficult, given the style of dining and the unpredictable schedules of all of the students. The goal of our project is to reduce food waste at a university level. We plan to do this via a dynamic model powered by near real-time student data and historical dining hall data, as you can see on the left. This will better generate predictions and therefore reduce the food waste at Rutgers Dining Hall. If you look at the top right, it's a screenshot of our web application that students will be able to put in their inputs for planned meals. And at the bottom right is a dashboard that the dining hall manager will be able to use. You'll see a demonstration of both of these later in the presentation. The ultimate vision of our project is to reduce the food waste that comes with poor food planning.
To review the market, we researched how food demand is forecast in the industry. We wanted to get a feel for how every sector forecasts food and use the best qualities of each to build our product. The visual shows some of the key takeaways of how dining halls, restaurants, and catering halls forecast food demand. We can see Rutgers Dining uses forecasting models based off of years of historical data, while many restaurants and catering services use moving averages to make their predictions. Our main contribution consists of our near real-time data retrieval through our application. This data attained through polls accounts for day-to-day trends and chance fluctuations of food demand by allowing students to select what they plan on eating. This will be augmented by historical data going into advanced forecasting using various boosting algorithms, regression models, clustering, and correlation. The data attained from these various techniques will be displayed in an interactive dashboard for dining hall managers and food planners.
Okay, so our product in action, essentially how our product fits into Rutgers Dining Hall in particular. So our product begins with students inputting their plans meals into the web app here. This data combined with historical data feeds into a model that is then represented on this Power BI dashboard. The Power BI dashboard and model outputs an ingredient order list that the food planner and dining hall manager would use to make orders for that week. Throughout the week, the food manager records food consumption and then inputs the week's food consumption back into Power BI. And the product ties together with that extra data. Sorry, 1 second. There we go. So the product ties back together and cycle starts all over again.
For our technology aspect, we've created a polling application using Django and Bootstrap. It will allow students to vote on what meal they intend on eating or if they intend on eating at all. So when you come to the website, you'll be greeted by this front page. Welcome to RU Food Forecasting. From here, you'll be able to choose which day you are voting on. So I'll go ahead and click Monday for this. Here, you'll be able to basically pick whether you're choosing for breakfast, lunch, or dinner. And I'll choose dinner. And I think I'm gonna have a Philly cheesesteak for Monday's dinner. So I'll go ahead and vote that. And once you see this vote, you'll see it's registered in the system right here.
Okay, so for the science portion of our project, this involved data cleansing, relationship creation, exploratory analysis, and then finally demand forecasting. So as far as data cleansing and relationship goes, COVID-19 had a pretty big impact on our ability to obtain historical dining hall data and any dining hall data for this past semester. So this led to us using Kaggle, which is a large data science community where people kind of just publish data and allow users to work on it any way they please. So we were lucky enough to find a data set that displayed food demand for 52 different items over the course of 145 weeks. And this data would be used for our proof of concept of our model and how it would work with our dashboard and application data. This image here shows the data relationships from the data that we have online. So the next part of our science is exploratory analysis of that data. So most of the more advanced analysis was done using several Python packages in Jupyter Notebook, but a lot of the basic stuff was done within Power BI. So on the left, we have a basic landing page with the previous week's food demand. And this is just a sort of high level view for the dining hall manager or food planner to go in and look at and get an idea of the last week's demand. And then on the right is a more in-depth showing and an interactive exploratory analysis page that shows moving average as well as clustering and correlation plot. So we can see here that it is interactive, and you can choose cuisine, food category, and so on. So the final part of our project, or the science portion of our project, is the model. So we have the Python model here displayed in our Power BI dashboard. And what you're looking at now is just the complete model. So for all the specific foods, the boosting algorithms ran, and the final model versus our actual for our data sets. And then moving along, you could see more specific to certain food items here. So for this particular instance, we'll be looking at meal number 2581, which is cuisine Italian category pizza. And we have past demand, particular models that we're looking at, and then a combination of the models based on past performance, so weighted based on past performance. And these models output the ingredient order list, as I mentioned before. And then that is also interactive in that you can select different food types and ingredients. And then finally, tying it all together, you can go into, once I click over there, the last week data input. So this is a place for the dining hall manager to import historical data so that that past week's data is then fed into the model, keeping up with the dynamic nature of it.
Okay, so jumping into validation and testing for our model, we utilize JMP to create multiple iterations to build a best fit regression line for our observed values. We then fitted our predicted values against this regression line. Next, we aim to calculate a mean absolute percent error. This is used to test the accuracy of our model as it measures the mean percentage error over the 20 observed data points. This yielded a 5.83%. We then analyzed the R² value to show the goodness of fit for our predicted values around the best fit regression line. We have a pretty high R² value of 0.82. And then we tested and mapped out the residuals for the complete 20 iterations. And then lastly, we have a distribution of our residuals. Okay, so jumping into project management, task distribution was broken up into hands-on project development of the application and our predictive model. Validation and testing began with testing a sample set in our observed data set against our predicted and ensuring functionality of the app as it integrated with our model. The main risks were the COVID-19 restrictions that everybody's been mentioning. These restrictions severely limited access to quantitative and qualitative data for our app and within the model. And this limited our ability to collaborate. Okay, so summing everything up, our unique product helps to reduce waste and save money by proactively planning food and utilizing advanced modeling techniques. This is accomplished by collecting near real-time data from students in an easy to use web application, combining that with historical data, and then finally presenting those forecasts to the dining hall manager in an interactive and intuitive dashboard. We believe our product can make a significant impact in reducing food waste and building a more sustainable practice within the dining halls at Rutgers.